Hey guys, welcome to the video. So today you're going to be assigning S and R configurations to molecules. So first thing we want to make sure that we have is an asymmetric center, which just means that our center molecule, which would be this carbon here, is attached to 4 different groups. So in this example, we have a carbon attached to a bromine, that's 1, a methyl group, that's 2, a carbon and a carbon, but this carbon is attached to a chlorine, and this carbon is attached to a carbon. So that makes our 4 different groups. Now, the first thing we want to do when assigning S and R configurations is to label our substituents with their priority. So the priority is going to go off atomic number. So this bromine is going to win first priority because it's got a higher atomic number. We're comparing it to these other carbons because they're all directly attached here. So first we would go bromine, carbon, carbon, carbon. Bromine has the highest atomic number, so we can go ahead and put a 1 right by it, okay? So now we have a carbon, and a carbon. This is attached to a carbon, this is attached to 3 hydrogens, and this is attached to a chlorine. So that's gonna win because it's got the highest atomic number. So we'll go ahead and put a 2 there. Now we can look at these 2 carbons, carbon with 3 hydrogens, carbon with a carbon. Automatically, that's going to win, okay? Now, we have a 1, 2, 3, 1, 2, 3, 1, 2, 3, going in this counterclockwise direction. Because our substituents are labeled in this order, this is an S. So if it's going counterclockwise, it's going to be an S molecule. Whereas if it was going 1, 2, 3 this way, then we would label it with an R. Okay, so moving on to this next example is a little bit different, but let's start out with that same first rule, which is assigning priorities. So nothing changes here. It's the same molecule. We can go ahead and assign priorities again. So this bromine is still going to win because it's still the highest atomic number. Okay, now we have got our carbon, carbon, and carbon again, but because this one's attached to a chlorine, this one's going to win. The chlorine has a higher atomic number than hydrogens or another carbon. The carbon beats the hydrogens, so this is going to be at 3. So now you may think, okay, well, it's going 1, 2, 3, 1, 2, 3. We can go ahead and label this S. But we have to stop and look at this a little bit deeper. So our lowest priority here is this 4 on this methyl group. Now, when assigning S and R configurations, always keep in mind that your lowest priority substituent needs to be on the dash. You can't have it on the wedge like this. It has to be on the dash. So we started out with this being S, right? But because this is on the dash, we have to change it to an R, okay? And if it works for you too, you can always try to sketch it in to kind of remember that, okay, you know, I have to flip them. But this has to be on the dash, this methyl group here, your lowest priority substituent, whatever it may be. Let's go ahead and look at another example here with these 2 molecules. So here we have our asymmetric center, this carbon. It's attached to a hydrogen, a methyl group, an ethyl group, and a alcohol right here. So we can go ahead and assign priorities again, now that we know we have a asymmetric center. So oxygen is going to beat the carbon, the hydrogen, or this carbon. So we can go ahead and label this 1. Then we've got our carbon connected to another carbon, a carbon connected to 3 hydrogens, and this hydrogen here on the dash, which the dash is going away from us into the paper, and the wedge is coming out at us. So we'll go ahead and label this a 2, and this a 3. Okay, so now that we've got these labeled, 1, 2, 3, we'll go ahead and make sure that our lowest priority is in the right place. So we have this H is our 4, right? And it's going away from us into the paper on this dash. So we're good. We don't have to switch anything. We're going 1, 2, 3, 1, 2, 3. This is going to be an S configuration because it's going in that counterclockwise direction. Okay, so go ahead and look at this molecule next. We still got the same one. So we got this carbon. We've got a alcohol group coming out going away from us into the paper on the dash. We've got a hydrogen coming at us, a methyl group, and an ethyl group here. So we'll go ahead and assign priorities just like usual. This oxygen is going to win because it's got the highest atomic number. It's directly attached to this carbon. Then we've got to look at this carbon and this carbon. This one's connected to another carbon, and this one's connected to 3 hydrogens. So we'll go ahead and name this 2, and this 3, with this being our lowest priority substituent. So just like that one example on the other page, this hydrogen, our lowest priority substituent, is coming at us on the wedge. We can't have that. This needs to be on the dash. So even though this looks like an S, we're going to label it an R because that's what it is. This has to be on the dash going away from us. So we just go ahead and flip that configuration, and that's it. All right, and that is how you label S and R configurations on molecules.